what we're going to try to do is build a Revit wall that is controlled by curves in Rhino and the algorithm in Grasshopper. So to get started, we're going to draw a line in Rhino. Just make this 0, 0 so that we can see where the origin is in Revit. Just click that and then do a curve here. In fact, let's see if anything has loaded. No, so nothing is showing up yet. If we do a preview toggle, see, now we can see the line in Rhino. If we move it, you see it updates. Okay, so for our purposes, we're going to turn it off and set one curve, which we've done. And what we want to do is draw a wall in Revit. So let's go to Revit. You have the wall tab, click add wall. Okay, so we add wall curve and then we click our curve and try to see this. So you can see that the center point in Revit is the origin. Like here, this you can essentially see where the origin is. So if we have to move this so it's a bit more central, we can do that. Okay, so let's view this in 3 dimensions. That is our wall. Just going to adjust this a little, and you can see as we're adjusting this, this is, just give it some color. This is a wall in Revit. Okay, and so now it's asking for a type. Okay, and so for a type, what we're going to do is choose what's called a model category picker. So you pick that. Now, for those of you who are familiar with Revit, you'll recollect that Revit is organized in a hierarchy, starting with categories, families, types, and then instances. So what we're trying to do here is select the wall category in order for us to get information, the next level of information. You select this, and this also has something called a type picker. This is a weird one because it takes in the category and then automatically gives you all the types that exist in that category. Okay, and so this is the information that we want. Okay, we click on an 8, but let's step back. You can see in Revit this type is an 8. Okay, let's change this to exterior CMU, maybe EFIS, and change that. Okay, brick, what would that give us? Doesn't look like much is happening. Do we? Oh, showing up here. So then we set the level that it's affiliated with. If you hover over, it says a level, and we can do that by going to input, and there is a level picker. So this lets you can see that this file only has 1, 2 levels. We'll be setting more levels as we go. So we want this hosted to level 1, put level right there, and then the height stands for the unconnected height in Revit. If you're familiar with Revit, you can see that there is an unconnected height that is 20. So what we're going to do is, let's do a 10 to 50 and connect that height, and you will notice that unconnected height has changed to 10. and you can, adjust this as you wish. It's mind-blowing. This is Grasshopper controlling Revit geometry instantaneously. Okay. And then location line, because if you've drawn a wall in Revit, you will notice that there are different places or positions for how you locate your wall. And in this case, we want a wall location line. So is it going to be in the wall center, or is it going to be the finish face? We click that. Okay, and you will notice now that if we do a finish face, you can see that it moved from finish face exterior to finish face, and you can see the movement. So we have the ability to control. If we wanted the wall center line, we can see that line, and the wall is in the center as well. Flipped is going to take a boolean, and so a boolean, you want to do a toggle so that you can always choose if you want to flip or not. And in this case, it doesn't look like we want to flip, or rather maybe we do, so that we can appreciate the brick. Okay, right, let's see if we can change this to something a bit more dramatic. There we go. See, we can modify this however we please. This is unbelievable. And then if we want to allow joins, that's something we can do. In this case, we have one wall. There isn't any complex joinery that's happening, but we can allow. And structural usage, so is this something that's going to be accounted for in structural analysis? These are things that come inherently with Revit walls that Grasshopper has exposed us to, so we can set this if we need to. So now we have our wall. Okay, what if we want to start working with the shape that we developed in volume 2, where we had the curved shape? So what we're going to do is do a shape like this, and then apply it to our curve. Oops, all of a sudden it breaks. What does it say? Why does it break? Right, curve must be a horizontal line, arc, or ellipse curve. So Revit walls do not work with splines. They don't work with, this is a NURBS curve. So what we're going to do is figure out how to convert this to a series of arcs as that match this as close as possible. Before we get into that, let's go into Revit to try to draw this. You'll notice that to draw a wall in Revit, click on wall, you can see all the ways you can draw a wall, and from here you notice that there is no way to draw a wall with a complex line. So even if we draw a line, model line that is a spline, okay, let's just say we're doing the same thing here. Okay, and we say a wall that we're going to draw by picking line. Notice that it's not letting us select this line, because again, Revit doesn't naturally draw walls with splines. And that makes perfect sense, because in the real world, constructing this will be difficult. But if you had like a very easy radius or some dimension that you can construct this by, not that it's impossible to, but it's not necessarily the most practical shape to construct. So even Revit doesn't let you do that. So if you look, going back to 3D, if you look in the folder that accompanied this tutorial, we have a Grasshopper cluster which we've put together to help you convert this curve into a series of arcs. We won't be getting too deep or getting into how that cluster was created, but for more information on how the cluster was created, feel free to join the Discord, our Discord channel. The link is below. And so let's bring in this Grasshopper cluster that will help us to create a series of curves. So to do that, you go to File in Grasshopper, you go to Insert Cluster into File, and it should take you to wherever you stored the folder for this project. I'm going to click Curve to Arc, and then boom, it showed up here. So what I'm going to do is connect this curve to this, okay, and it needs an arc count. So how many arcs will it take to get as close to this curve as possible? So let's do from 3 to 10. Okay, now I'm going to connect 10 to this. So if we zoom in, you can see it creates an arc, a line, and an arc. So as we start to adjust this, it starts to get real close. So it's almost like detailing it out. So let's try and get as close as possible to this while maintaining a minimum number here. So we have this, and now we can connect these arcs. So if we just see what's coming out from here, I have arcs, and so we connect these into here, and then voila, now we're able to, now they're segmented. Let's view them on plan. This is where we can now leverage whether we want them to be joined. So I'm just going to copy this and connect this to true, and you can see that in plan they now show up as joined. But if we turn this off, it shows up as separate walls. But because we want them joined, we'll click false, and then go back to 3D. It's still going to show up as the lines, the break lines, you will see them, but yeah, if we do that, this syncs up. And the awesome thing now is, as we adjust this, you notice that it starts to adjust. But there was an issue with the sweep, so let's try to do this for another wall. Let's do this for a curtain wall, storefront. Okay, let's see what this does. Oh, look at that, fantastic. Now we're able to, and notice that let's move this back here. Going to adjust this, and it's adjusting like very well. Okay, we can get as complex as we would like. Okay, but you can tell that it's not. So as we adjust these segments, you will notice it gets finer. Exactly. But for our case, we're just going to keep it this way. Something you can decide to do is make sure your script responds to either a straight line or a complex curve. A way to do that is to use the stream gate, which you learned in either volume 1 or volume 2. I believe it's volume 1. So we do a stream filter, stream filter. Okay, this takes in some index value, and if this index value is 0, the value here is what comes out from here. If it's 1, the value here is what comes out from here. So the best way to do it is to test whether our curve is a line. Okay, so what we're going to do is just draw a line, or get a line input and connect this curve to this, and you notice what it says: data conversion failed from curve to line. Okay, but what's coming out from here? We get a null. So we want to test. Let's test for null. So null item. Okay, and you can find this. So if you hold down Control Alt, it will take you to where you can find this, and you can find this in the sets toolbar, the sets bar. Okay, and then we're going to connect this. Let's just clean this up a little bit. So what's coming out from here is that it's the null is true. And so what we're going to do, let's test this out. Let's select this curve. Let's set one curve. Set this. See, the null is false. But this curve will generate no arcs. Okay, that's why nothing is coming out from here. So what we want to do is false. If we connect an integer, when you connect false, false is equal to 0. Okay, and true, let's set this again, is equal to 1. Okay, so what we can do is connect this null value to this stream gate, and you will notice that it takes in values from here. So I'm going to feed in stream with 1 and feed in the stream 0 with the line. Okay, so what happens is, if this curve is a line, it will always give me the line as an output. But if it is not a line, it will give me a series of arcs. Okay, so now I'm just going to connect this to my wall, like that. Let's get this out the way. Let's clean this up a little bit. Okay, we can do without this. Keep our parameters together. There we go. So if we set this line, so set 1, now we have this thing responding to whatever kind. Okay, remember, you can modify it. Okay, so that's essentially how you create a wall in Revit using leveraging the Rhino.Inside Revit technology. Something else that I didn't mention is assuming we want to, create a wall again. Okay, so let's just go to Revit, go to wall, and then add wall. Okay, and then connect. Let's do another curve, and then we connect just this one that we have here. Okay, and connect it. Notice that we didn't put any type element. It just automatically selected a type. Well, the type it selected is the basic wall generic 8, and that's because when we draw a wall in Revit, it always automatically selects a type for us, and the wall that was selected was wall type 8. Okay, so if we change this to generic 12, now that's the wall that it will automatically select for us. So if we do wall again, see, so now I'm going to delete this one, do a wall, maybe even delete this wall, put this curve here, and then you notice that this wall is generic 12 because it automatically sets that. And then the levels, just going to delete this, and then the levels of the wall, if you notice, let me select, and let's talk about the levels. The levels, you can see that the base constraint is level 1. If we set this to level 2, it sets the base to level 2, but change the base offset to -10. Okay, so the levels doesn't necessarily mean that the base of the wall would move up to that level. The wall actually stays where it is. The levels also stay where they are, but what changes is the base offset. So that's something to also take note of. So it's not like nothing changed except from the fact that you have the base offset as 0 now. The next thing we'll be working on is how to modify these Revit panels in a curtain wall.